What's up, guys? Hey, Doves here, and we're back with another LeetCode problem. Doing LeetCode every day till I get a job. That's the plan, anyways. Um, this is the hard problem I was talking about the other day. I figured out what's wrong with my solution, and I feel kind of stupid for it. We're gonna show the solution I came up with, and then I'm gonna explain it, and then we're gonna go back and look at the other problem I have. Let me open my Coke. Oh yeah, that was crispy. Solid Coke, but. We're going to go back over the solution that I used to have. It's the same exact thing. I just took my code out of a function and put it into my loop, and it ended up working fine. And then I'll try to explain why that solution didn't work. And I could have changed one line and it would have worked. Or I could have changed like two lines and it would have worked. But today we're going to do the problem 25, reverse nodes in K group. Given a head of linked list, reverse the nodes in the list K at a time and return the modified list. K is a positive integer and is less than or equal to the length of the linked list. If the number of nodes is a multiple of K, then the left out nodes in the end should remain as is. That's saying that this list is the length of 5, K is 2. So in reverse 1 and 2, so we want 2 and 1, and then we take the next 2, which is 3 and 4, and then we get 4 and 3. And since 5, the remaining nodes is not like divisible by 2, we want to keep them as is. Showing a little more here, since it's a length of 5, and K is 3, we take 3 nodes, and then we reverse them. So we take 1, 2, 3, get 3, 2, 1, and the last two are not our last remaining nodes are not 3, so we want to leave them as is, right? So I tried to solve this a few days ago, and my solution was fine. Like my logic was there. I'll explain that at the end. But we're gonna get right into the solution because I've recorded this twice now, and my audio really didn't pick up well. So we're gonna have a list node solution equal to new list node. We're gonna pass it a dummy variable, and we want this to point to the head. And then, like always, we're gonna return solution next, and then we want to list node. We're gonna have a previous head, and this is gonna be equal to solution. And then we're gonna have a list node current. Well, current is going to be equal to head, and then we're going to create a list node tail, and it's going to be equal to current, or it could be equal to head too. So these are the four nodes we have. And the reason we're keeping up with these 4 nodes is because I guess my previous work. So we have this dummy node here that points to the head of our list. The reason we don't want to keep up with the actual head of the list, so say we had our solution node point to 1. 1 is now the second in the list, and we don't want to return that. So we keep up with the, we keep a dummy node here. And then that's why we have previous head equal to it. So when we link everything around, previous head is going to be pointing here. We're going to break that link, and previous head is going to be pointing to 2. We want 2 to point to 1. Break this link, and then we're going to have 1 pointing to 3, right? And that's kind of what we want our algorithm to do. And the reason that's why we keep up with this, so solution.next is this 2, and we're going to return that node, and that's going to be the first node in our grouped, reversed, whatever you call it, the what they call it, the reverse nodes in K groups. So now that we have all of our our nodes in place so we can get into our while loop. So while current does not equal null, we want to loop through this guy, right? And then the first thing we want to do is we want to create an int I equal to 0. And the reason we want to see for the I, this I is keeping up with how many times. So we have our current and we have our tail. And we want tail to go k times. So k.next is 2, and then k.next is 3. So, and we want tail to keep up with the node after the 2 that we want to link right here. So we want to reverse these two nodes and then put 2 where 1 is. And we don't actually want to put them, we just want to like kind of do the links around. Like we just want to swap them around. That way when we follow the linked list, it ends up being reversed for the first two nodes. So we want tail is at where current is, but we want tail to be where 3 is, right? So that's why we keep up with the I. And then in the situation that current is 5 and tail is 5, because every time we come back into the beginning of the while loop, we want current to be here where tail is, and then we're going to increment tail 2 times. Then tail's going to be where 5 is, and then we're going to increment current twice. Current's going to be where tail is, and then we're going to come back to the while loop. This would be our, I guess, our second iteration for this example. And then 5 points to null. This is how you know the linked list is at the end. So if current goes once, we're going to check to see if tail is equal to null, because tail is going to point to this null value. So if we increment tail, tail is equal to tail.next. And we're going to check to see if it's null, and if it's null, we're going to break out of the for loop. And then if the I is less than the k value, that means it didn't progress that many nodes. It didn't progress 2 nodes. It progressed 1 node until it reached null. That means we don't have k nodes or 2 nodes to swap around or reverse, right? So this is kind of making sure that seeing if we're at the end or we even have something to reverse. So we can do for I is equal to 0. So we want to make sure tail does not equal null. We can put that together to make it a little bit more readable. And we want to make sure I is less than k. And do I plus plus. And we said tail equal to tail.next. And then if I is less than k, we want to go ahead and break. And then now we have this dummy node right here that holds 0. It's pointing to the first node. Our solution is this node, and then our pointer head is also, or previous head is also this node. So now that we have all of our node references where they want to be, we want to go ahead and reverse the list. So we want list node equal to cur.next, or we're going to name the list node. Next is equal to cur.next. So the reason we want to keep up with the current.next is so we can reroute the cur.next is equal to tail. So what these two lines does is it our tail would be here. Let me raise that up a little bit. So our tail's here. We created a next node pointing it to 2, so we can break this link and then reroute the current to point to tail. So that's what we want. We want 1 to point to the next node. And then when we reverse these two, we'll make sure 4 is here and 3 is here. But for the first iteration, assuming that they're not, you can assume this bottom one isn't linked, isn't completed yet. The values would be 3 then 4. So we want 1 to point to 3. And then after we've done that, we want to make sure our condition to break out of the while loop, because if you can imagine if k was like 5, we want to make sure that our condition for this middle loop would be, well, outside the while loop, what we want to do is we want to set previous head dot next, and this is going to be equal to the current. So all this is doing is it's linking the current to the tail, and then this is linking the previous head equal to the current, and we want the current to be here, and then we want current next to be here. So when next is equal to tail, that's when we want to break out of this while loop. So while next is not equal tail, we'll continue iterating in this loop. So we want to create a list node previous, and we want that equal to current. That way we can set current equal to next, and then we can set next equal to the current's next. That way we don't lose references to these nodes when we break their links, because right now they're all linked up. We want to make sure to keep up with the links we break so we can reroute them and not lose a node. So now that we're keeping up with the current node, we can set current is equal to next, and then we can set next is equal to current.next. And now that we have that, we want cur.next to be equal to previous. So if we go through the first iteration of this, so before we break out of this, the first thing we did is we set current, and we set the current.next equal to next. So we're keeping up with this to node right here. Now that we have this node, we can break this link and set current.next equal to tail. All right. Now that we have this link, we want to make sure to keep up with this node that we're at currently. So we go into the while loop, and we set previous equal to the current. Okay, and then we set current equal to next. So current would be here with next. And then we want to set next equal to current.next. So it'll be down here with tail. And then when we do that, we want to make sure to relink it backwards, because we're trying to reverse the list. So we don't want it to point forward. We want everything to point backwards. And then so for this example, the while loop will only iterate one time, and then it will see that next is equal to tail. I said current was here. I probably said next, but wrote current. The next is right here with tail. And since next is equal to tail, we're going to break this link of the previous head, and then we're going to set it equal to the current. Previous.next equal to current right here. Now that we have that, as you can imagine, this it's probably easier if I wrote that in black. These values right here is the 3. It's the 3. This is 4. And then when this algorithm breaks and we run the previous head.next, there will be a dummy node here. Go back blue. The previous head. This is pointing to 2, and then 2 is pointing to 1, and 1 is pointing to 3. So previous head is pointing to 2. Current is here at 2. I can't see that. So current is actually pointing at this 2 value right here. And then 2 is pointing to 1, 1 is pointing to 3, and then tail is at 3. So we'll go ahead and put tail here. And what we want to do is we want to increment C to 1. We want to increment it k times, right? So we want it to be at 1, and then we want it to be back at where tail is. And then we want the pointer head to be incremented twice as well. So I'll do pointer head is 1, and then we'll increment it one more time. We want to increment it k times, which is 2. I'll increment it once, increment it twice, and then previous head will now be at the previous value. And then once we have T and C are the same values, and then pointer head is the not point. I keep on saying pointer head. Previous head is the node behind it. We can go ahead and do the loop again and reverse the next two nodes and then relink them. And then once we get to the end, or tail reaches null before k times, we know that we don't have to reverse any more nodes. So we can do for I is equal to 0, I is less than k, and then we do I plus plus. We want to set previous head equal to previous head dot next, and current equal to current dot next. And this should be a valid solution, at least for did I do plus equals? We meant plus plus, of course. As long as I didn't miss a semicolon, speak of the devil. When I go explaining, I forget to write semicolons. As you can see in the test results, we were given 1, 2, 3, 4, 5. K is 2, so we want to reverse 1 and 2, and then we want to reverse 3 and 4, and that's what we did. So we get 2 and 1, 4, 3, and then 5. And that was the expected output. And then for case 2, we get a k equals to 3, so we want to reverse 1, 2, and 3. And since there's only 2 nodes left and not 3, we just reverse the first 3 and leave the last 2 the same. And then we just submit the solution. It should be a 1 millisecond runtime. Yeah, 1 millisecond beats 30%. That's pretty nice. There's faster solutions with recursion, of course. That's what I was looking at here at the end of the last video I recorded. We could probably get into recursion. I don't know too much about recursion. This one didn't make too much sense with the recursive calls, right? So it will return 2, 4, 3. Yeah. So the recursive call right here, that's when you call the function again inside of it. It returns a list node, and you see they also keep up with the tail, and that would be the value after. So what they're doing is they're reversing these two, and then they're passing this linked list into the call, and then it reverses these two, and then it passes this linked list into the next call, and then it returns it sets this node's .next value equal to the returned head, which would be 5 here, and then it sets the 2's .next value equal to the returned node, which would be the 4, like the head of the reverse list. And then it just slowly rebuilds the linked list, right? And then at the end, it will return the head, which would be the 2. That one's fairly cool. I didn't come up with that solution. It's always good to go back through the solutions tab and look through them and make sure you understand them. But I wanted to show you all my solution I came up with. Thought this algorithm is, I mean, it's not too complicated, but yeah, I thought it was pretty good. We can go ahead. I will show y'all where I messed up in my first solution, and it's exactly the same. The algorithm and logic is exactly the same. I just did one big hiccup, right? One really big problem with it compared to this one. Let me go ahead and fix a few things so I can show you all this. So I copy and pasted my first solution into a note add Excel, and this is it. So as you can see, what I did to solve this was instead of having this code here, we can go ahead and comment, do a comment block. I called reverse the list, and then I passed it the previous head. I passed it the current, and then I passed it the tail. Now, if you look, if we copy this code and paste it right here, it's exactly the same. Literally nothing different with it. Now you may ask, what's the problem with this? And if we run it, we can go ahead and see that it doesn't give us a valid solution. Expected semicolon. We'll go ahead and run this. You'll see the test cases fail. And it says current.next is doesn't sort. Anyway, I was like, okay. I was like, why is that null? So I just said if current it's not equal null. We'll go ahead and run the statement. Oh, I put if current does not equal null, we'll run that statement. And then I was looking, and then I was like, that's exactly what we didn't want to do. So we outputted 2, 1, 4, 5. And when we wanted 1, 2, 4, 3, 5, I was like, this is what I was stumped on. I was like, what happened? The code's exactly the same. The code inside the function and the code for the solution I gave you was exactly the same. I was like, what happened? So I'll tell you what happened. When we passed the pointers inside of the function, or the references, we have the pointer head here for the first pass, of course. Pointer head here, it points to this node, current's here, tail is here, and we pass this into the function, right? So the function gets all these three values that we passed it, and it creates brand new reference variables, right? So we have a reference variables in our scope, it has a brand new scope, and it has brand new pointer head, current, and tail. So pointer head and current stays exactly the same for the function. But if you notice, the current head gets incremented one time inside the function. So my logic was that when it links one more time, current would be where the 2 is, right here. Tail would be here. This was 3, this was 4 for the first pass. And then, pointer head would be here, pointing to the first node. So this was the logic I implemented. But this is what happens inside of the function. This is where all the references are inside the function. But outside the function, when it breaks out, our current is still pointing to 1. Well, the current is here. And not where I want it to be at the 2 value. So what we do for our call is we increment current by 2. So current is pointing to 4, and then pointer head is pointing to 1. And they're 2 nodes apart. That's not how my logic worked. My logic worked that current was exactly 1 node after the pointer head, and then the tail was exactly k after the current. But the way my logic ended up being was that the current is exactly 1 behind the tail instead of k behind the tail when it does the if, not the if, when it does this for loop. And that's why I was getting a null error, and I had to check for the null, because current was here and tail was here. We incremented current by 2, and now current past tail, we go to the beginning of the while loop, tail gets incremented by 2. It does the reverse for just these 2 nodes, so nothing happens. And then current gets incremented by 2 at the end. And now current is a null. So that's where all the errors came from, is because functions have completely different variables than what's inside from where the function was called. Now both references point to the same object. So the object is the same. So anything you do to the object will be done to the object outside the function. But the reference variables are not the same reference variables. They're two completely different reference variables. And that's where my logic kind of broke. And so, this is where I was stumped, because I figured my logic, like conceptually, I figured I was right. And it is right. I just copy and pasted the code outside the function. So the way you could solve this is if you return a list node, and at the end of here, if I returned current, and we can go ahead and delete this. And if we set current equal to this and run it, it should work. Yeah. So I figured that the current inside the function is the same current here. So when I incremented, where is it at? When I set current equal to next, and we broke out of the function call, the current in here was not equal to the same current inside the function. And so if we return the actual current at the end of this, it fixes everything. And it broke my little brain. So if we run that, it actually works. And there it goes, beats 14%. Beats 14% in memory, beats 1% in that. Anyways, but I think that's going to be all for today's episode. Today's episode was a little long-winded. I spent like 3 different times recording it. As you can see, 34 minutes ago I recorded it. But I'm about to go in the bedroom and get some sleep and chill with my girlfriend. But I will catch you on the next video. Tomorrow we will be doing another LeetCode problem. I think it's going to be our last linked list problem. And then I think we're going to go to binary trees or just some other data structure and another algorithm so we can get some more practice in. The recursive function would definitely be better for this. If you see there's only 0 millisecond problem. This one uses recursive calls. I grabbed this from the solutions tab. It just breaks down the reverses block by block, and it returns the head of each reversed all the way to the end till it builds the final reversed linked list problem. But anyways, y'all stay blessed, stay healthy, and I'll catch y'all in the next video. Hey devs, out.